problems. Thanks everyone for your patience. So now, let's start the talk, talking about AI and security, lessons, challenges, and future directions. So everyone here is really excited about the new advancements in AI. AlphaGo has one of our world champions. And also, we really experience this now. Deep learning is empowering everyday products. However, on one hand, as we experience this exponential growth of the power and applications of AI and deep learning, on the other hand, we are also seeing another type of growth in a different domain in the landscape of security. Unfortunately, in the landscape of security, we are seeing a different trend where attacks are increasing in scale and sophistication. So, for example, recently we've seen the Mirai botnet, which has compromised over 400,000 IoT devices across over 160 countries, including security cameras, baby monitors, home routers, and so on. And these IoT devices have been used to launch one of the biggest distributed denial of service attacks on the internet at its peak, has over 1 terabit per second combined attack traffic. And also many of you probably have heard about the WannaCry attack, which is one of the largest ransomware breakouts. Again, this ransomware has infected over 200,000 machines over 150 countries in just a few days and asked victims for Bitcoin payment to unlock encrypted files. And also, we continue to see really large-scale data breaches. For example, in the recent incident from Equifax, attackers have stolen over 140 million users' sensitive information. And also, we see that attacks are entering new landscape as well, including power grids and also sophisticated banking systems. So from all this, we see that there are these two trends going at the same time. One is in AI and one is in security. And there are a lot of really exciting and important questions at the intersection between the two, AI and security. And in particular, when we look at the intersection between AI and security, we essentially see two directions. One is how can AI impact or help security? For example, how will the rise of AI alter the security landscape? On the other hand is how security may impact AI. For example, how will the security or insecurity impact the deployment of AI? And these are the main questions that I will describe and also help you walk through a little bit in this talk. So first, let's look at the first direction. How will the rise of AI alter the security landscape? So the good news is that we've already seen that deep learning is improving our security capabilities as well. So for example, face recognition has been widely deployed at many places, in particular in China. And this really helps with user authentication and so on. And also we have seen examples where deep learning techniques have been used for more effective malware, vulnerability, and fraud detection. Here I'll just briefly mention one concrete example from our own work in how to use deep learning to help solving some of the really important security problems in the area of IoT, Internet of Things. So as we all know, Internet of Things is really growing really fast, and it's estimated that by year 2020, we have over 50 billion such IoT devices deployed over the internet. Unfortunately, many of these IoT devices are plagued with vulnerabilities coming from the use of third-party code. And they use a lot of third-party code, and in particular open source third-party code. And when someone finds a vulnerability in a third-party code, it's very important to then try to figure out really quickly whether a particular IoT device firmware is using this vulnerable third-party code. However, here we are often dealing with program binaries that run on different hardware platforms. And hence, we need a very efficient and effective way to very quickly tell whether a given IoT device firmware is actually containing some vulnerabilities, some of these vulnerable functions. And this is a challenging question, again, because often these functions or this software they actually are running their binary programs compiled for different hardware platforms. So in this, to solve this problem, we have done a recent work using deep learning to essentially convert these firmware, these binary programs into, so first of all, we extract code graphs from the software, and then using deep learning to compute what's called an embedding. So essentially, these are vector representations of these binary functions, and in the end, to do similarity detection between the firmware functions and the vulnerable function. So the advantage of using this approach comparing to previous approaches is that one, it's much more efficient. For both the training time and serving time, we can get orders of magnitude improvement over previous work, and also in terms of accuracy, using deep learning can help us gain significant accuracy as well. So this is just one example of how we can use deep learning for automatic vulnerability detection, and also potentially in the future for patching as well. And also, in the longer term, we're also investigating and exploring some new directions and techniques how we can use deep learning to even enhance and also enable other new types of security capabilities. So one area is in automatic agents for attack detection, analysis, and defense. Here's one example of a new direction that we're exploring. So currently, a statistic has shown that over 80% of the attacks today, they actually start with social engineering attack, such as phishing attack and so on. So one of the great application is that how we can use AI to help solve this problem. So for example, people have been talking about using AI to develop chatbots, which can help you to book flights, find restaurants, and so on. So in this case, to combat phishing and social engineering attacks, a new direction that we're exploring is to develop NLP techniques to build chatbots that can monitor the email and online communication between the user and the potential attackers, the correspondents, to detect potential attacks. And in this case, the chatbot can actually even issue active challenge and response to a potential attacker to protect the user from phishing and social engineering attacks. Another domain is how we can use AI to improve software security. A lot of the security problems comes from the vulnerabilities in software. And wouldn't it be nice if we have techniques that can provide provable guarantees that the software actually satisfies certain security properties and hence will be free of certain classes of vulnerabilities. So in this domain, we are exploring new directions, leveraging new techniques such as deep reinforcement learning, which has been used to develop, for example, AlphaGo. Instead of using it to play games, we are actually using such techniques to train agents, with the hope that the trained agents can then be able to learn how to do proofs, and using the techniques to then enable us to do program verification, so we can automatically verify that a given piece of software is free of certain classes of vulnerabilities. So of course, these are really grand challenges. Any progress we make in these directions can really significantly help us to improve the status quo of software security. So this is one direction showing that how AI can enable new security capabilities. In the other directions, AI also needs security. Security can enable better AI. So when we talk about AI, when we deploy AI, it's really important for us to consider AI in the presence of attacker for a number of reasons. So one, history has shown that the attacker always follows the footsteps of new technology development, or sometimes even leads it. And also, this time the stake is even higher with AI. As AI controls more and more systems, attacker will have higher and higher incentives to attack the system. And also, as AI becomes more and more capable, the consequence of misuse by attacker will also become more and more severe. So when we talk about AI in the presence of attacker, there are at least two types of questions that we need to consider. One type is how the attacker may attack AI. Attacker can attack AI in many different ways. For example, to cause a learning system to not to produce intended or correct results, or even cause a learning system to produce targeted outcome designed by the attacker. And also, attacker can also try to learn sensitive information about individuals from the AI systems. To address all these problems, we need to have stronger security in the learning systems. The other type of question is how attackers may try to misuse AI. Attacker can try to misuse AI to attack other systems, for example, for finding vulnerabilities in other systems and devise new attacks. To solve these problems, we need stronger security in other systems. So first, let's look at how attacker may attack AI. Here, let me just give you some simple examples. So what you can see here is on the left columns, these are the original images, which are correctly classified by the image classification system. And in the middle columns, that looks a little bit like noise. So these are called adversarial perturbations, which are perturbations that are specifically crafted by the attacker. And here they are magnified so you can see them. Without the magnification, they are really small that you can barely see them with human eyes. And the right-hand side, these are called adversary examples. So these are essentially the original images with the adversary perturbation added to them. And the interesting thing here, as you can see, is that between the original images and the adversary examples, as you can see from human eyes, they look almost identical. But however, the adversary examples here, these are specifically crafted by the attacker to show that to misguide the classification system, and in this case, they are all misclassified by ostrich. So this is an example showing that these deep learning systems are really easily fooled. So why should we care about this problem? So here, let's look at a scenario in self-driving cars. When we have self-driving cars, they will be driving around and they will be observing the environment. For example, recognizing speed traffic signs to make the correct decision. And these are some photos from the traffic sign in Berkeley. So one question is here, you can already see on the traffic signs there may be some marks just done by some humans. But what if the attacker actually tried to essentially perturb these traffic signs by putting on some stickers or something, so that to human eyes, you can still recognize these traffic signs perfectly, but however, they'll cause the image classification system to misclassify. So the question is, can this actually be possible? Can this be real in the physical world? Another way to ask the question is, can we actually develop these adversary examples that are actually effective in the physical world that would remain effective under different viewing conditions, such as viewing distances and angles and so on? So this is one of the questions that we set out to investigate in our recent work. And what you see here, these are examples, actual physical adversary examples where you can see for these traffic signs, for some, the perturbation is really small. It's hard for human eyes to even see. And for some, you can see there are stickers put on these traffic signs. And the important part is that for these traffic signs, they can all cause the image classification system to misclassify, in particular when they are viewed from different viewing distances and angles. And in this case, they are all misclassified to speed limit sign instead of stop signs and so on. So here's a video that I wanted to show. Okay, so what you will see here is that you'll see two frames side by side. The right hand and at the bottom, once I start playing the video, you will see the labels given by the image classification system. And what you will see is that the car will keep driving towards the traffic sign here. But the right-hand side is the original traffic sign without any perturbation, and the left-hand side traffic sign is a traffic sign with adversary perturbation. And then you'll see, so now let me... Okay, right. So as can see on the right-hand side, for the original traffic sign, the image classification system is correct. But for the left-hand side, for the traffic sign, actually the image classification system remains to be ineffective. Like it misclassifies it, misclassifies the stop sign as a speed limit sign. So as you can see, this is a concrete example showing that such adversarial examples can really cause serious issues when we deploy these autonomous systems. So this is just one example. We actually have done a lot of work in the space showing that unfortunately adversarial examples is not just limited to image classification system, they are actually prevalent in deep learning systems. Unfortunately, I don't have time to go into the details. So we will investigate the different types of systems, including visual question and answer systems, which given an image, I will try to tell you the answer to a question. And also, to skip this. And also, even in the setting of deep reinforcement learning, when we train deep reinforcement learning agents, we can also develop these adversarial examples to fool all these systems, including the visual Q&A systems and also the deep reinforcement learning system. So again, I don't have time to go into the details for this, but what you can see here is the left-hand side is the original frame, and the middle is the frame with adversarial perturbation, which shows us the same agents that can work really well in the original frame, but when you add adversarial perturbation, the same agent will be completely fooled and fail completely. And also in this case, as you can see from human eyes, you actually can't tell the difference between the original frame and also the frame with the adversarial perturbation added to it. Unfortunately, so this is another example demonstrating that such adversarial attacks can be a serious problem to the deployment of deep learning systems. So again, I won't have time to go into the details, but so what I've talked about essentially is examples in adversarial machine learning. We're showing that attackers can, at the inference time and also later at the training time also, can develop these attacks to fool the learning system to either give the wrong prediction or even to learn the wrong model. And adversarial machine learning is particularly important for security critical systems. Overall, I strongly believe that security will be one of the biggest challenges in deploying AI. And when we talk about security of learning systems, we actually need to look at it at several levels: the software level, the learning level, and the distributed level. Again, I won't have time to go into the details. A big part of our research, and also I think this is also a really important area for the whole community, is to look at how we can, at all these different levels, to investigate and develop new techniques and approaches to improve security of the learning systems at these different levels. And so far, I've talked about how attackers can attack AI. And also, another really important problem for us to keep in mind is that attacker can also try to misuse AI to attack other systems. For example, there has been work showing that deep learning can enable more effective bug finding, can enable more powerful phishing attacks, and also deep learning has been used now in the real world by the attacker to try to solve captures, for example. So overall, there are lots of really exciting questions at the intersection between AI and security. For example, how to better understand what security means for AI and learning systems, how to detect when a learning system has been fooled or compromised, how to build better resilient systems with stronger guarantees, and how to build privacy-preserving learning systems. Overall, security will be one of the biggest challenges in deploying AI, and it requires a community effort. Let's tackle the big challenges together. Thank you.